In this video, I'm going to do a quick overview of the periodic trends. So the first trend I'm going to talk about is atomic radius, and I have a couple different variations of the definition there, but really it's talking about the size of the atom. When we talk about atomic radius, or any of these trends, what we want to do is look at what their trend is going down the periodic table and left to right across the periodic table, and then you should be able to answer any of the questions that go along with that. And what happens is you go down a column on the periodic table, the atomic radius increases. And it's because you are adding more and more energy levels into this electron. So it's naturally going to get bigger because the electrons are taking up more space. They're moving farther away from the nucleus. But the other thing that happens is the shielding effect will also increase. The shielding effect has to do with the amount of inner electrons, so electrons between the nucleus and the valence shell. The more inner electrons you have, the higher the shielding effect. And the shielding effect is just really the lessening of the attraction between the positively charged nucleus and the outermost electrons. Now, as you go left to right across the periodic table, the atomic radius decreases. What happens here is, say we're talking about sodium, right? You have the nucleus in the middle, you have two energy levels, well, three energy levels. And you keep adding more and more protons in this nucleus as you're going left to right across the periodic table. But the electrons are all being added to that same valence shell. So you're not changing the number of inner electrons here. So shielding effect remains unchanged as you go across the period. But what happens is the effective nuclear charge increases. And the effective nuclear charge is really just that attraction between the protons and the valence electrons. Since you're getting more protons and shielding effect is not changing, the effective nuclear charge is increasing, and it's really allowing the protons to pull on that valence shell of electrons a little more strongly since you have more protons, and it causes that atomic radius to decrease. So the general trend is as you go down they get larger, and as you go left to right they tend to decrease in atomic radius. Now the next trend is ionization energy. It's how much energy it takes to remove an electron from an atom. So when we look at this as you go down a column, the ionization energy is going to decrease. Remember, we are getting larger and larger atoms because you keep adding all these energy levels on. The shielding effect is increasing, so the nucleus can't hold on to those outermost electrons as well just because they're farther away, and you have these inner electrons blocking the nucleus from holding on to those outer electrons. So it ends up being easier to take an electron away from the nucleus when it's farther away and it's being shielded. Now as you go left to right, the effective nuclear charge is increasing, and that has to do with the shielding effect remaining the same and the electrons being added to an existing energy level. Right? That's why the effective nuclear charge increases, and that's why the atomic radius decreases. Now what that means is the nucleus, since it has a higher effective nuclear charge, the nucleus can hold on to those outermost electrons more strongly, so it is now going to cause an increase in ionization energy. It takes more energy to remove an electron from a smaller atom with a higher effective nuclear charge than from a larger atom. That is the general trend for ionization energy. And go to the next trend. The electron affinity. There's a couple different definitions you could use. The first one's given there, energy given off when a neutral atom in the gas phase gains an extra electron. Simplify that is the desire for an extra electron. So as you move down a column, electron affinity is going to decrease. Again, you're adding more and more energy levels, so shielding effect is going up. So what's happening is in these larger atoms, like these large alkali metals, they're having a hard time holding on to the electrons they have. So they don't really have much of a tendency to gain any extra ones when they have a hard time holding on to what they already have. Now, as you go left to right, electron affinity is going to increase. And again, what happens is the effective nuclear charge is increasing, right? You're adding electrons onto an energy level that already exists. The shielding effect is staying the same. Overall, the radius is going down. So this higher effective nuclear charge is saying that these elements with a high electron affinity, like the halogens, for example, they end up having a tendency of gaining extra electrons. If you can think about elements as wanting to do something, although I kind of hesitate to use that, but they want to be like the noble gases, so they have a tendency to gain electrons to get a stable electron configuration. And the last one is electronegativity. Now, one of the things about electronegativity, it has to deal with when these atoms are forming a bond. It's the ability of an element to attract electrons when the atom is in a compound. The other way you might see it is when they're forming a bond. So it's the only one that has to do with when they're bonding. As you go down on the periodic table, the electronegativity is going to decrease. What happens is you're getting larger and larger atoms, so the shielding effect is going up. The electrons, again, those valence electrons are farther away from the nucleus. So it's kind of like, it's related to electron affinity a little bit. They tend not to pull extra electrons to themselves because there's so much blocking the shielding effect from the inner electrons and the outermost electrons. Since there's so much shielding going on there, the nucleus does not tend to pull any more electrons towards itself. As you go left to right, electronegativity increases. That's for the same reason as the last two. Effective nuclear charge is increasing. So that nucleus is pulling electrons towards itself more. So when they have a bond where electrons are being shared, they will pull themselves more towards their own nucleus than, say, an alkaline metal would. That is a general overview of the trends.